Hello friends, let's solve this A-level mathematics question. The question says solve for x and y given e raised to the power of x plus y equals to 6, e raised to the power of x plus e raised to the power of y equals to 5. You can present your own solution in the comment section. So let's solve together. Solution. So we can rewrite this equation as e, applying the indices rule, e raised to the power of x times e raised to the power of y, which is equal to 6. We call this equation of 1. Okay, so the second equation still remains. So we have e raised to the power of x plus e raised to the power of y is equals to 5. Let's call this equation 2. Now, we can say from equation 2, let's say from 2, from equation 2, let's make e raised to the power of y subject of formula. So we are making e raised to the power of y subject of formula. Okay, then we have e raised to the power of y is equals to 5 minus e raised to the power of x. We call this equation of what? 3. So we can now substitute. Let's substitute. We can now substitute equation 3 into equation 1. So let's substitute equation 3 into equation 1. So if you do that, we are going to have e raised to the power of x times, we call that e raised to the power of y is now what? 5 minus e raised to the power of x, which is equals to what? 6. Now, let's multiply e raised to the power of x times 5. That gives us 5e raised to the power of x minus e raised to the power of x times e raised to the power of x equals to 6. So we move further by saying 5 multiplying by e raised to the power of x minus e raised to the power of x times e raised to the power of x. That gives us e raised to the power of x squared, which is equals to 6. So from here, we can represent something. So let e raised to the power of x be equals to p. So wherever we see e raised to the power of x, we write what? P. So we have 5p minus 2 minus p squared, sorry. This is e raised to the power of x, which is p, then the square, equals to 6. I can decide to subtract 6 from both sides. So I will have 5p minus p squared minus 6 equals to 6 minus 6. So since I have subtracted 6 from both sides, 6 cancels 6 here. So I have 5p minus p square minus 6 equals to 0. This looks like a quadratic equation. So what do? Let's move our p here. So we have minus p square plus 5p minus 6 equal to 0. So we can multiply all by what? By minus 1, so that our p square will not be having a negative sign. So if you do that, we are going to have p square minus 5p then plus 6 equals to 0. So if you solve by factorization method, we are going to have 5p square minus 2p minus 3p plus 6 is equals to 0. So something is common here, that's p into p minus 2. Something is also common here, that's minus 3p minus 2 equals to 0. So which means p minus 2, then p times p minus 3 equals to 0. So from here, I can easily say p minus 2 is equal to 0, or p minus 3 is equal to 0, which easily give me the value of p to be equals to what? You move minus 2 to the right hand side. So it gives us 2, or p equals to 3. But recall p to be equal to e raised to the power of x. Recall that p equals to what? E raised to the power of s. Now, if that is the case, now let's look at it when p is, let me break it down from here. So if I break it down from here, so when p is equals to 2, then we are going to have, since p, from here, since p is e raised to the power of x, so we are going to have 2, or let me say e raised to the power of x equals to what? Equals to 2. So let's find the natural log of both sides. If you find natural log, we are going to have in e raised to the power of x equals to 2 equals to in what? In 2. In 2. So in and natural and e cancel, then we have our x. Our x to be equals to what? In 2. Now, when p is equal to what? NP is equal to 3. So we have e raised to the power of x to be equal to what? 3. So if it is that, behind the natural log, we have in e raised to the power of x to be equals to in 3. So we have our x to be equals to what? In 3. Now, that is that. But recall that we are also to find the value of y. Okay, so to find the value of y, we are going to make use of equation 3. This equation that says e raised to the power of y equals to 5 minus e raised to the power of x. So we come here, e raised to the power of y equals to 5 minus e raised to the power of x. So when x is equal to what? In 2. So we are going to have e raised to the power of y is equal to 5 minus e raised to the power of in 2. So what we do, e and in cancelled, then we have e raised to the power of y to be equals to 5 minus 2, which means e raised to the power of y is equal to what? 3. So let's find y. So let's find the natural log. Have in e raised to the power of y to be equal to in x, in 3 rather, sorry. So from here, our y is now what? In 3. So that's that. Now, when x is equal to in 3, so we have e raised to the power of y, e raised to the power of y to be equal to 5 minus e raised to the power of x. Okay, so we have e raised to the power of y equals to 5 minus e raised to the power of in 3. Okay, in 3 and e cancelled, so we have e raised to the power of y to be equal to 5 minus 3. So we have e raised to the power of y to be equal to what? 2. So we find natural log of both sides. In e raised to the power of y equals to in 2. So this cancelled, so which means our y equals to in 2. So our final answer now, or let me say our final solution. Let me write it in form of x and y coordinates. So we have x, y. That implies that when x is in 2, y is in 3. Then when x is in 3, y is in 2. That's the final answer. Thanks for watching. Don't forget to like, share, and subscribe to this channel. Thank you. Bye bye.